So last time, which is yesterday, we stopped here. Yesterday we started discussing Java, for those who weren't here yesterday. We spent most of the lecture discussing why Java, what is the mindset of Java, why it's different than C, and why it's very important to understand the mindset rather than the syntax itself. Because we mentioned the syntax is very similar to C, but the way you program is the different thing, right? Good. So we discussed multiple things, had our very first program in Java, and we stopped here at arithmetic operations. I told you that arithmetic operations in Java are very, very similar to C. There are very little differences. And one of the things that we need to know is we already have this from C, but maybe it's more advanced or a little bit. You have more options in Java, which is doing typecasting. What is typecasting? Typecasting, if you have a variable of a certain type and you want to copy this to another variable. By default, both are of the same type. But what if they don't? What if they don't have the same type? Then in this case, maybe you get a syntax error because you cannot convert from the right side of the assignment operation to the left side because they have different types and you cannot convert from one to the other. Maybe it's done automatically. The compiler is smart enough to know that, for example, if you have a float variable and you want to assign to a double variable, this will happen by default. Why? Because double is a superset. You can think of this as a superset of the floating point numbers. Both are representing the same thing, but double has a wider representation. Float is 32-bit, double is 64 bits. So it's safe that you take 32 bits, put them in a 64 bits, right? So this will happen by the compiler by default. You don't even need to do anything. But the third thing is, it will not give you a syntax error. The compiler will not do it by default, but you have to do something. This thing we call casting. So you have, if you want to assign two variables of a different type, then you do something that we call casting, both in C and Java. Casting is basically telling the compiler, I want the result of the right-hand side of the assignment operation, whether this is a variable or an expression. I want the result to be in a certain format, right? With the example here, we have two variables of type byte. I told you yesterday a byte is an 8-bit integer, right? And then x is 12, y is 34. I add both in Java. Yesterday we discussed that byte, short, what else? We had a third one. White, short, and then int is 32-bit, and then we have the long int, which is 64-bit, right? So just go back a little bit here. So byte and short, byte is 8-bit integer, short is 16-bit, and then the default one is int, which is 32-bit. Any operation you do in a short or a byte integer variable, the result, any math expression you make in these variables, the result would be an integer thing, 32-bit by default. Even if here x and y are bytes, you may expect the result to be byte. But in Java, it's not the case. Why it's not the case? Because if you add the maximum two values of a byte is an 8-bit, so the maximum value is, and this is a sign thing, so the maximum is 127, good? If you add 127 plus 127, which both are valid bytes, the result will not be a byte because you will exceed your limits, right? The result may be a short because it's 16-bit. So the Java compiler just like do it the default way, which is anything you do in a short or a byte, the result is an integer thing, 32-bit. So this is a safe side, right? Here I'm adding 2 bytes, but the result is int. What if I want my result to be also byte? In this case, you need to do casting. Good? So you need to tell the Java compiler that add these two numbers. I know by default your result is int, but then please cast this to byte. Why this doesn't happen by default? Because you are changing from a wider variable to a narrower one. I told you that the expression result is int, which is 32-bit, but you want only to represent this in 8 bits. So moving from a wider precision to a shorter one doesn't happen by default in the compiler. I told you that the opposite happens by default, right? But moving from end to short or from end to byte doesn't happen by default, and you need to cast it yourself. What is the result of this casting? It's basically the 8 bits, the least significant 8 bits of the result. Good? Is that always safe? What do you think? Would you expect that the result of this exhibition is always correct? What are the cases that this may not be correct? Any idea? Yeah? Yeah, they exceed the value of the byte representation. The example that I gave you, that if you add the two maximum numbers that are representable by bytes, like 127 plus 127, you need 16 bits for this, or actually you need just 9 bits, but we don't have 9 bits. So this is not always safe, but given that you know what you are doing, the compiler will allow you to cast from a wider to a narrower precision. Good? This is basically casting. So I already told you that a value of a narrower type may be assigned to a variable of a wider type without casting. This happens by default in the compiler. One example would be moving from short or byte to int, or the other example that I gave, moving from float to double, right? But then conversion from narrower to wider is called widening, that's okay. So these are the general thing of doing widening or the casting by default in the compiler. I move from byte to short, this is by default is okay. From short to int, that's also okay. From int to long, the reason is long is 64-bit, int is 32. So it's still safe, right? And then long to float, a float to double. Good? And then, so one trick here. Float is just 32-bit, but long is 64-bit. How it's safe to do long to float? This is for a bonus mark. So the question again, I told you that it's safe to move in this direction because each one has a narrower precision than the wider one, so it's safe. But yesterday we discussed that long is 64-bit integer, while float is just 32-bit floating point representation. This is 32, this is 64. Why it's safe to do that? And the compiler does it by default. This may require some digital design or logic design knowledge. It's a bonus mark. Do you guys know how to represent a floating point in hardware, right? Did you know this before? Yeah? But float are also only numbers, right? Yeah, float is like a floating point number, like it's, yeah? Not much, yeah?
Well, I remember learning when the float, you basically have like the mantissa, and then you have basically the exponential where you
exactly
28 minus 1,
yeah.
and then
that's
with that
yeah.
you just have basically a binary string.
That's true. Yeah, thank you. So the thing is, yes, in float I only have 32-bit, but this is the thing that is good about knowing what's happening in the hardware. Float is only 32-bit, but actually it's able to represent numbers larger than the 64 integer. What happens in the long is you have 64 bits, but all of them are integer variables, like the normal binary representation you guys know. Like every bit is just a 0 or 1, and then you do the binary conversion to decimal, and that's it. So the maximum number you can represent in 64-bit is 2 to the power 6. If it's signed, then it's 2 to the power 32 minus 1, right? But in the float case, you only have 32 bits, but we split them into parts. The mantissa part or the magnitude part and the exponent part, and then 1 bit for the sign. But just doing this, you are able to represent a wider range of numbers, right? So although we have less number of bits, you can here represent more numbers than the long. And this is what is important, right? You only lose precision if you represent less number of numbers, right? But if you represent larger number, then... So what if the other thing that is in this slide, we discussed just casting from a type to a type. What if I do a math expression in 2 different types? So we had the example of x and y, both are bytes, and then I wanted to convert the whole expression. But what if I have x as a byte and y as short, or x as a byte and y as int, and I add x plus y? what's going to happen is by default the compiler will cast the narrower one to the wider one. Because the result, if you know from like basic math, if you are adding two numbers, the result is, the width of the result is equal to the largest number plus 1, right? If you are adding 8 bits plus 16 bits, the result can be up to 17 bits, right? This is by default, right? So you cast the shorter to the wider by default. The compiler will do this for you, and the result will be of the longer. So if you are adding int plus long, the result is long. If you are adding int plus short, the result is int, right? And the other thing is any integer type and float are converted to double if the other operand is double. If you are adding int and float, the result is float. If you are adding float and double, the result is double. So shifting. So I don't know why I'm assuming that you guys have some kind of binary or basic digital design thing, but this doesn't seem to be the case, right? How many of you already know some basics of digital design? What are AND, OR gates? What is binary, hex, decimal representation? Can you please raise your hand? Yeah? Okay, so it seems that at least some of you know, right? So the thing is, what is a shift operation? Good? A shift operation is you have a number. Let's say we're talking about this number now in bytes, in bits. Let's say you have 8 bits and you shift it to the left, right? So what you are doing is you are inserting some bits at the least significant side. So you do a shift, right, towards this side. So we have left shift and right shift. Good? The thing about, and this is what is important in this slide, the thing about right shift, we have two types of right shift. Can someone say what are these? Also for a bonus mark? Yes? Yeah, yes, like 95% correct. So you can shift it by adding zeros, which we call just the normal shift operation. But also we have what we call arithmetic shift. The problem is for sign representation, the last significant bit is your sign. If it's 1, that means it's negative. If it's 0, that means it's positive. So if you just add zeros and your most significant bit was 1, then you are losing your sign. You are converting a negative number to a positive number. Good? Then we have what we call arithmetic shift, arithmetic right shift, which is you see what is the most significant bit and then you add this. So if it was 0, then you also still keep adding 0. But if it's 1, you add 1s. So we keep the sign. This is called sign extension. Good? So this is why we have two types of right shift here. This is the normal shift, which you just add by zeros. And this is the arithmetic right shift, which is you look into what is the most significant bit and then you add this. I don't know if I need to review some of these, but assume we have this number. This number here, right? If this number is unsigned, we know from C we can represent signs as signed and unsigned. If this number is unsigned, then the last one here, the least, like the most significant one, does not represent anything. It's just a value. It doesn't have any sign representation. So in this case, it's okay to just shift right the normal shift. So shifting, for example, by 3, you just add 3 zeros here, then you lose these least significant 3 bits, right? But on the other hand, if exactly the same number is a signed number, that means this number, the last one, represent a negative value. So it's a negative number. Good? In this case, you cannot just shift by adding zeros because you lose the sign. So what you do is you shift, if we shift by 3, by using the same bit as the most significant bit. So if it's 1, then you shift by adding 1s here, right? This shift is the arithmetic shift, which is done in Java by these 3 arrows thing. But just doing 2, you only add by zeros. Good? We don't have this problem in left shift because the most significant bit is the bit that has the sign. Whatever you add at the least significant doesn't really matter. Good? Is there any question? Good. So also some of the binary manipulation things, you can do bitwise operations like AND, you AND 2 numbers. This is the AND gate. You OR, you XOR, or you negate. You can also do XOR, or this is the bitwise complement or negation. Yeah. So What if I have an if condition or a for loop with a condition? Then you need the same type of operators you had in C. This is equality checking. This is non-equal checking. This is AND to add two expressions together. This is OR, and this is NOT. These are exactly the same from C. So you guys already know what do they mean. So here there are some differences from C, and this is important to know. And the reason for this difference is in C we didn't have a Boolean type. In Java we already have a Boolean type. So if you do, we said this is already logic AND, logic OR, and then you start evaluating such expression. Here you are checking whether k++ is larger than 20 and then 4 is less than 5. What happens in the compiler is you start from the left side, you calculate your expression, is 4 is less than 5? Always true. And this is an OR expression. So the compiler will move step by step. I got a true, and then I'm doing an OR. You know from hypothetical logic design that ORing anything with true doesn't really matter because it will be always true. One ORed anything is 1, right? And in this case, what is important to know is the compiler will completely ignore this expression. It will not even calculate it. It saves time by saying, okay, the expression is always true, why I should care? What is the consequence of this? If you print k here, you will find k is still 10. You may imagine that k now is 11 because you already incremented it. This is a post increment, right? But you remember from C that post increment happens only after you calculate your expression. This expression is not even calculated, so the post increment will not happen, right? And in this case, k will still be 10. Good? This is very important to understand because if you look into the code, you may imagine that k now will become 11 because you already incremented it. This is not the case because the compiler will never happen to calculate such expression. Is there any question here? This is one of the differences between Java and C. Okay. Another difference is because in C we don't have a Boolean type, C is considering any integer value as Boolean. And you remember we said any non-zero value is true in C, right? So if you say not 56, what you would get in C? You will get 0 or false, right? Because 56 is always true because it's non-zero value, and not true is false, right? But in Java, this is syntax error. The reason for this is you already have a Boolean type, so you don't need this kind of expressions, so it doesn't do Boolean operations in integers except for 0 and 1. Good? So any non-zero or 1 value will not be valid for such logical and or not operations. Okay? Again, here you also have a syntax error. Here, let's see what happens, right? So I say 4 is less than 5. It's exactly the same expression we had before, but now we only have a bitwise OR operation. Good? And this is important to understand what is the difference between this, which is a logical OR, which represents an OR gate, and the bitwise OR operation here. So if you look into what is the value of k here, in this case it will be 11. So the calculation, that this expression will be calculated. The reason is, can someone imagine what is the reason? And then this is also another bonus mark. Why in this case? What I told you before is if we had the logical OR here, which is like these two stacks, this expression will not be calculated, and if you print k here, k will be 11. K will be 10, right? What I'm telling you now is this, in this case, k is going to be calculated, right? Why this is the case? Can someone imagine why this is the case? Yeah? And the reason, like why it doesn't short circuit. Yes, and why in bitwise OR you need to calculate all the expression. But also in the OR depends on both, right? you need every single bit to do your expression, right? In bitwise operation, you OR bit by bit, right? You need both expressions to look into their bits, do it one by one, right? But in the logical OR, you only look for true or false, right? This is why in this case you need the value of both expressions. Good? Okay. So something that is very good in Java, and I told you yesterday that Java in general is easier to program with than C. This is the advantage of Java, because in C we needed fine-grained control. One of the advantages is you already have all kinds of operations in string. In C we didn't have a string type by default. So we needed to define arrays of characters and then do some operations on, right? In Java you already have a string type, a default data type called string by default. And in this case, for example, if you use the plus operator in a string, as if you do concatenation. If you do something like this, you define a string called good, another string called day. If you add them both, the result is good day. So it does concatenation for you by default. Right? We'll see some of this more in details, but I'm just giving you a big picture of what is going on. The other thing is, anything that is added to a string and is not of a string type will be converted by default to a string. For example, and this is very similar to Python. You can print something on the screen, say the number is, this is what you want to represent, and then this is a variable in your program, right? You want the number to be something like an integer variable. In this case, you are adding integer to a string. This is a valid syntax in Java, and the result would be x will be converted to string, and then if x is 10, so the number is 10. X will be replaced by its value. Good? Okay. We also have the conditional operator, very similar to C. What you do is you check the value of this expression. If it's true, you execute this one. If it's false, you execute this one. Good? We also have the dot operator, very important in Java. You remember when did we see the dot operator in C? When did we need it? Yeah. For structures, right? And the reason is, I told you dot is a member operator. So your structure has multiple members, and then you are accessing one member in such structure. In Java, it's mainly object-oriented. Everything is classes, and every class will have some members. That's why you need the dot operator, right? Another thing that we will use in Java is what we call an instance of. Because similar to C structures, you can define a structure as a data type and then have multiple instantiations of this structure, right? We had the monom structure in our example, and then we define mono1, mono2, mono3, right? As variables of this type. So that means mono1 and mono2 in our C example was an instance of the monom structure, right? So the same thing in Java, every class is considered a data type. So by defining a class, you define your own data type. And then an instance of means it's a variable of this class. Good. If else is exactly the same thing. Switch is the same thing. For while, do while, the same thing. Break, continue, exactly the same syntax. One thing that is different, this is exactly the same for loop in C. One thing that is different, let's skip this one. Okay, so I'll come into this later. But we have one difference in Java compared to C, which is an easy way of writing a for loop, right? But for now, for loop looks exactly the same as C, right? And this is a valid syntax in Java. Good. Variables in Java, the way you define them is exactly the same way you define a variable in C, except that you have more data types in Java. Good. So you have ints. The thing that is problematic in Java, and again, there is a reason for this, it's the mindset of the language. In C, we have heavy load in pointers, right? Actually, we spent 4 lectures in pointers. What are pointers? Are special types that hold memory addresses. Why this is the case in C? Because you need to handle the memory yourself, right? I told you need to take control of the memory, get the address of a certain variable, and you have the fine-grained control. In Java, you don't have this. You don't even manage memory in Java. Memory collection, memory handling is done in the background, right? That means we don't have pointers in Java similar to what we have in C. Good? We have some alternatives, but for now, the way we know pointers in C don't exist in Java. Okay? So arrays. You can define arrays in Java pretty much similar to what you do in C, but with some extensions. Okay? So similar to C, what does an array name represent in C? Yeah? Memory of what? Memory location of what? Of what? An array name in Java and C represents the memory location of what? Yeah, of the first element, right? So in Java, also the array name represent some kind of an object. We call this object, which is the OOB language, right? So it's an object that is representing the whole memory assigned to this array. Good. So here you define an array of double. As you can see, it's pretty much similar to C. The only difference is you can leave this as empty right now. Good. And because this is an object, you can think of, and this is an instance of a class. So the way you do this is after defining the array name, you need to know its size. And the way to do this is by using the new operator. The new word. This word will be used much in Java. We almost never used it in C, right? Why? Because new is related to classes. You are defining a new instance of a class or an object. Good? So you can think of new as a word that you use to define a new object of something. Here we defined an array, but we didn't know its size, and use the new reserved word to define an object of this array as a double array of size 12. This is how you read this line, right? You named an array, my array, but now it's not referring to anything. No memory even is reserved here because you didn't assign a size. Later, you make this my array as an object of a double array of size 12. So you read the new as an object of, an instance of. Right? It's very important in OOB. Right? Is there any question? What happens with this line is now you allocate a memory of size 12 multiplied by 64 bits because this is double, and then my array will be referring to it. Okay? Is there any question? Am I going too fast? I'm just skipping the information that we already discussed in C. If you have any question, let me know. Okay. So as I said, my array becomes a reference to the array, to the memory location of 12 entries. Each one of them is double in memory. Okay? So in Java, similar to C, arrays are by default initialized to zeros. And then to allocate, to deallocate the memory of an array, you can make the reference as null, which means pointing to nothing, so my array equal null. We already know null from pointers in C. And then there are more advanced or more capabilities in Java of operating arrays. For example, you can get the length of a or the size of an array using myArray.length. So now you use the name of the array as if it's a class, right? And this is important to understand. This is the dot operator, right? The member of operator. We only use this in structures in C, and I told you this means access the member of this object or this structure. How can I use this in an array? Because here, I already defined the array as an object of a double class. Everything in Java is instant of classes, right? So even when you define an array, as if it's an object or an instance of or a variable of type class of the arrays, right? That means it has its own member functions and member variables. One of these members is the length, right? Which is myArray.length gives you the length of the array. So in the case of the 20 or 12 that we defined here, this gives you like the length will be 12, right? It's kind of a new mentality than C programming, right? Arrays in C were completely different than structures or we didn't even have classes. But in Java, everything is a class. Even defining an array By using the new operator, it's an object of a class, which means it has its own members that you access using the dot operator. Good? Okay. So in Java, you can put the brackets, the empty brackets, before the variable name of the array or after it. And both are completely almost equal. The thing is, here, if you put this before, that means this applies to both A and B. So that means A is an array, B is an array. Good? But if you do it after A, that means B is just, what is the type of B? It's just a double variable, right? It's not an array. Good. And then here we are defining a double array called X, and it has 100 double elements. Great. To access the elements of this array, you can pretty much similar to C, say xi, which is the index, gives you element number I in this array. This is similar to C. So the way you initialize arrays are also similar. Here I didn't initialize it. What is written here is basically by doing this, yet you didn't fully define the array. So no memory is allocated. Why? Because we didn't use the new reserved word. New in Java is the word that go to the memory and reserve something, right? So you can think of new as like this. Once you have new, you go to the memory and allocate the storage that stores this array or store this variable. Good. Here, we didn't define new yet, and also you didn't define the size. So by doing this, D is not referring to any place in memory. It's not a complete definition yet. What do I need to do? You need to do something similar to this. New, double, and then you give the size. But not just only this. You can also do this thing. And from C, we know you can define the size of your array by just explicitly saying what is the size. Or if you initialize the array, the size will be the number of elements you have in initialization, right? So here C will have 7 elements. That means the size of the C array is 7, and in this case, this is a valid representation, and memory is allocated in this case. Good? Any question? So personally, I hate saying like kind of theory, keep talking about theory and many slides and keep moving without writing code or allowing you guys to write code. So help me in like passing through this thing, because if you have any question, let me know. Otherwise, maybe I can go fast and then we can start coding. Right? Yeah. The third, this one. So this one, read it like this. Define a double array called X, which is an object of type double array, and it has 100 elements. So it's like defining, like in C language, you define a double array of size 100, that's it. But because in Java everything is classes, you need to use the new object definition of a class, and then by this you allocate a place in memory. Okay. Is there any other question? Yeah, it's like array reference means you are really pointing to some place in memory, not just defining a variable. So by just doing this, there is no array reference, means you didn't allocate any place in memory. Okay? Okay, so we didn't have this as a valid syntax in C, which is allocating an array to an array, right? Right? In C, I told you if you have 2 arrays, A and B, you cannot say A equal B. The reason is, what was the reason in C? Yeah? Yes, you can have, but what if they are of the same type? Can be different, right? Yeah, but in general, even if the size is the same, in C, this is not a valid syntax. You cannot take a complete array, put it in another array, right? And the main reason is the names are pointers to the first address only. Right? In Java, the mentality is different. The array name is not a pointer to the first address. The array name is an object that has members, right? In C, we knew that you can assign a structure to a structure if they are of the same type, right? In last lecture of C, we had 2 structures, and we said mono 1 and mono 2, and we said you can have mono 1 equal mono 2. Good? This was a valid syntax in C. Why? Because you assign an object to an object. In Java, we said array names are just objects. By this, you can allow to do such syntax, which is assigning an object C to an object D. C is an array, D is an array. But the name of the array in Java is different than the meaning in C. The meaning in C is a pointer to the first address. The meaning in Java, it's an object of type array, right? So if both are of the same type, then it's okay to do that. Good? Is there any question here? I'm not very happy with you guys today, because there must be a question here. Yeah? You just copy every element to the other element.
So it just makes two new.
It's similar to what happens in structures in C. You take every member of this structure, put it in the member of the other structure, right?
Okay, so like it's not efficient. So it's like you're having two.
It's like a for loop, right? You just go through all the elements. But there is one thing, yep. No, you don't have to, but that's a good question. Why? Yeah, why you don't have to do this? Because, so let's say it in this way. You can define an object of a class using different ways. Using the new reserved word, or initializing it, or assigning another object of the same class to this object, right? This is the third type, which is, so your colleague question is the following. I didn't use the new word for the D by assigning D equals C, and you are telling me that this is a valid syntax. Why? What I'm saying is you have three ways of defining an object of a class. Either by using the new word similar to here, or by initializing it similar to here, because also in C we didn't use the new, right? And the third thing is to assign an object of the same type to this object, right? All three ways are valid in Java, but this is an excellent question that we'll touch on later. The question that I have here is, what if, and I told you one of the reasons in C, one of, like your friend said, one of the reasons why this syntax is not valid in C is that the array elements may not be equal. Like maybe C has 100 elements, D has only 10. Right? Right? So why now this is valid, right? Yep. Yes, yes, because just by doing this, D don't have any reference in memory. By doing this, D equals C, D will be another reference to exactly the same location in C. So we will come into this in one slide. If you change D to equal 10, what will happen is because D and C are referring to the same thing, C2 itself will change. So this line, as if D and C are pointing to the same memory location that holds all of this. If you change one of them, you would change the other one. Similar to in C, if you have two pointers pointing to the same variable, right? If you have two pointers pointing to the same variable, then you do change by using dereferencing one of the pointers, it will reflect on the other one, right? Because both are pointing to the same thing, effectively.
Doesn't create a separate copy, both referring to the same thing.
Yes, by doing this. If you want to refer to another place in memory, you have to use the new reserved word, right? Yeah, can we have a dynamically sized array in Java, right? No, we cannot, right? This is an important thing. You cannot. Yeah. Would you say this again? I don't get the question. So you are saying, what if? Oh, equal is just one equal? Equal is the checking operator, right? It doesn't, it's not an assignment operator, so you don't copy something. It's not a valid syntax here, right? You cannot check whether an array equals another array or not, right? Okay. So one of the differences in arrays in Java that we didn't have in C, yeah. Yeah, so these are different ways. Okay, so let me put it in a different way. I told you also that arrays are not dynamically sized in C, but we had ways to do this using pointers, right? So what you're saying is we have ways to do this in Java, which I agree with, but we did, like, the question itself is no, arrays are not dynamic sized by default in Java, but there are ways to do this, right? And we'll come into this later. Thank you for the addition. Your friend is saying, yes, arrays are not dynamically sized in Java, but there are ways to do it. Yes. And in C, we have the same thing. If you define an array pointer to an array or memory location, you can have a dynamically sized array in C, right? But it's like you need to do an extra step. It's not just by default. Okay? So in C, we had the problem of, because you have a fine-grained control, again, the mindset, there is no boundary checking for the array size. So if you define an array of 10 elements and you access element number 20, the compiler will not complain, and you go to this memory location, either read it or write it. And this is very risky, as we discussed before. In Java, because we don't have this fine-grained control, and the compiler does a lot of work for us, it does have an array boundary checking. So if you access an element that is outside of your array boundary, the compiler will not execute this line and it will throw away an error for you, right? Which is safer, I guess, right? Good. Here is finally a piece of code. You define an array. So what we do is, the first line, we already discussed these two before. You define an array of integers. It has 6 elements. And then what we do here is you are referring to the third element of this array. Print line we have seen yesterday as well. So what will happen is array element subscript 3 is, and you access this. Can you expect what is the result of this line? What you will see in the screen? Yeah? 0, not garbage, because we said arrays are initialized by default, right? So it's 0. What about the second line? Yeah? It will give you an error, as we see here, right? And the reason of the error, it tells you that array index out of bounds exception. So something that is good in Java is the compiler gives you some meaningful errors. In C, it gives you a message that you don't even understand what it is, right? And you need to debug yourself. But Java, it has some good error messaging there because they have the error handling techniques by throwing an error, right? Using try and catch. So what does it tell you is you are out of the bounds of the array. The reason is element number 6 does not exist in an array of size 6. What is the maximum size of an array 6? 5, because you start from 0 to 5. So this is out of the bound. Good. So it combines successfully, but through execution, it gives you this error. Good. So this is the thing that I told you 5 minutes ago, is for loop in Java is exactly similar to what you do in C, but there is also a special type of loop if you want to loop through an array, or in general, some data structure. Good. This is, you just say for type variable array. What does it mean? Is you loop through all the array elements one by one. Good. So let's see an example. So here, what we do is you have an integer array called test. It has 1, 2, 3, 4, 5 elements, and we want to loop through this array. In C, or generally in Java, what you would do is you define for int equal I less than 5, I plus plus, right? And then you keep looping through the array. But in Java, the shortcut is you say for int, you call it I, number, whatever, and then you say this is in test, right? Which means for every single element in test, say number equal test and check it, right? So this is just a shortcut for looping through elements of an array. There are some disadvantages here, right? The disadvantage is, what if I don't want to loop through all the elements? I just want to skip some element, because in the general for loop, your condition can be anything, right? You can, for example, loop through only the odd numbers or the even numbers, or just you skip 5 elements and you go through, you increase your counter by 5, right? Here, the counter default value is just 1. Each time you increase your index by 1, right? So if you want to do something more advanced than looping through all the elements, then this is not good for you. But because most use cases is you loop through all the elements to do something, right? Then this shortcut is maybe helpful to you. Okay, so the other thing is, okay, the time saved you guys from another quiz. Okay. So the last thing we discussed today for these last 2 minutes is double subscript arrays. Exactly the same thing from C to Java, except for one thing, right? This is exactly the same thing. You access this element, you initialize the array, you have the length. So one thing here is AI is referring to, so in C, you wouldn't be able to refer to only if you have a double subscripted array, you cannot just use one subscript. So you cannot use that in C. But in Java, every single subscript, if you have aij array, AI is referring to one row of the matrix, right? And why this is also the case, because the mindset that every one of this is an object of its own, right? And then you have object of objects, good? So you can refer to elements of just a single of